Hey guys, in this video I want to show you how to estimate the default probability of a corporate bond. There are several ways how you can do this. You can use credit default swaps, or you can just look at the rating agencies. But in this example we're going to come up with a default probability by using the bond's present value. Consider the following bond. It has a maturity of 3 years, a principal of 1,000, 4% coupon payments, which are paid out semi-annually, and a yield to maturity of 3%. We can solve for the present value and get 1028.49, and we have a recovery rate of 40%. The recovery rate determines how much is left after the bond defaults, so the price the bond trades at after a default event occurs. Here we've set this to approximately 40%. Over here you can see our yield curve. I've only plotted it for the first 3 years because only these bonds are really irrelevant, and these are the spot rates on zero coupon bonds which are risk-free. So the first thing we have to do if we want to come up with the default probability is we have to value this particular bond as if it would be a risk-free bond. So what I've written down here are all the payments, and I've discounted them back at our spot rates over here. If we sum them up together, we get the present value of our bond as if it would be risk-free. So what we can do now is we can use the rate function in Excel to solve for the yield to maturity on this risk-free bond. In this example, it's 1.39%. So now we can calculate the credit spread. This is the difference between the yield to maturity on the corporate bond and the yield to maturity on the risk-free bond. In this example, this is 1.61%. So this is the extra compensation investors demand if they invest into the corporate bond instead of the risk-free one. So we're going to come up with our first rough estimate right now using this particular formula over here. This formula is very easy and it's quite intuitive as well. It says that the credit spread consists of the recovery rate and the default probability. So we can actually rearrange this equation since we know our recovery rate and we know the credit spread. So we take the spread and divide it by 1 minus the recovery rate, and we get a default probability of 2.68%. As I've said before, this is only a rough estimate. So I've linked a paper down in the description, and this paper kind of disregards and falsifies this equation, and it says that this equation is not applicable on real-world default probabilities. Just because it makes the assumption that the default probability is always higher than the spread, because the recovery rate is bound between 0 and 1. So the spread can never exceed the default probability. However, this paper has shown that in 2014, 98% of the corporate bonds he investigated showed higher credit spreads than default probabilities. So this formula here is really questionable. But now we're gonna go on to a more precise way of estimating a bond's default probability. For this, the first thing we have to do is we have to calculate the expected loss if we invest into the corporate bond. We can calculate this loss pretty easily just by taking the difference between our present value of the risk-free bond and the present value of the corporate bond. So we get 47.89 euros. This is how much we would expect to lose if we invest in the risky bond. Okay? So let's go over to the next table, and what I've written down here is how we can come up with the present value of our expected loss and how we can solve for the default probability. Let's start here on the left. What you can see here, these are the spot rates from before, these spot rates here. And here are the forward rates. These are important for this example. if you look at similar tasks, a lot of times then the task makes the assumption that we have a flat yield curve. This makes things very easy, but it's not very practical. So in this example, what we have to do is we have to calculate the forward rates. I'm not going to go into detail now how to calculate these forward rates, but I can tell you that these forward rates here are the forward rates in 1 year for 1 year, and these are the forward rates in 1 year for 2 years, and these are the forward rates in 2 years for 1 year. Over here you see the payments for the different periods, and here is our unknown variable, the default probability. We make some assumptions here as well. We say that the default probability is unconditional on previous default probabilities and that it is constant. So that it is the same for the maturity of the bond. Here's our recovery rate on how much we expect to recover if the bond actually defaults. So we assume that our recovery rate is going to be constant over time and that it is a percentage of our principal value of 1,000. And now what we have to do is we have to value our bond as if it would be risk-free for different points in time. So the first one is fairly easy. We just take our payments here and we discount them back at these spot rates. You might ask yourself, but wait a second, we've just estimated the risk-free value of our bond and it was 1076. Why is it higher now? Well, it's because this here is the cash price or dirty price as well. So it incorporates accrued interest. And here we have accrued interest of 20. Yeah, so these are going to be paid out soon, because when is a bond going to default? Most likely it's going to default shortly before a coupon payment. So we have 6 point in times where we assume that a default can occur, and this is always shortly before a coupon payment. So this incorporates all the accrued interest, and that's why it's a little bit higher. So now we have to come up with estimates on the present value for future points in time. The first one is pretty easy. We just have to use the spot rates. But let's take this one here, for example, in period 3, after 1.5 years. What we have to do here is we have to use our forward rates, because at this point in time, this bond has 2 more years to maturity, so we have to discount back the first payment at the 1 year spot rate and the second, and these 2 payments here, at the 2 year spot rate. We cannot use the 3 year spot rate and 2 year spot rate again. And so we have to use the forward rates, which are going to develop into future spot rates to discount our risk-free value here. This is very important, that we do not use these spot rates here. So here I've used our forward rates in 1 year, and for the last 2 payments I've used the forward rates in 2 years. Now we have to estimate how much we're going to lose if we default. Since our recovery rate is 40% and we recover approximately 400 euros, we can just subtract these 2 values and get our loss given default on these 6 potential default occurrences. What we do now is we discount them back, these losses, with this discount factor. And this is important here. When we calculate this discount factor, we use today's spot rates again. We do not use these forward rates anymore, because all of these payments are going to be discounted back to today, whereas here we have discounted back to a future point in time. That's why we needed the forward rates. So when we discount our losses given default, then we get these values. If we sum them up, we get 3,821.02. But obviously this present value we have to multiply it by the chance of a probability of default. This is how much we would lose if it defaults on one of these payments. But what is the default probability? Yeah. So what we can do now is we can go back, because what we've done here is we've already calculated our expected loss from the bond. So we can make a new equation. We can set them equal, our expected loss and the present value of the expected loss times our default probability, and then we solve for x. So we can rearrange this equation, take our expected loss, divided by the present value of all our expected losses, and we get a default probability of 1.25%. This default probability is more accurate than the one we've calculated before and gives a pretty good estimate. However, if we compare this default probability to real-world default probabilities, then we can see that even this default probability usually overestimates the default probability in the real world. Why is that the case? Well, it's because when we come up with this default probability, we assume that investors are risk neutral. However, in the real world, investors are usually risk averse. So they demand a higher compensation for taking on risk than a risk neutral investor would do. So for this bond, we've just looked at, then the appropriate risk neutral default probability would be 1.25%. However, investors demand higher premiums, so for a lower default probability in the real world, these investors demand the same price. And this is why this value usually overstates default probability, but it's still a good value to calculate with and make predictions.